Today I'm going to solve this puzzle, XV Magic by NurglesGift. Let's take a look at the rules. Normal Sudoku rules apply. So again, we need the digits 1 to 9 in every row, column, and 3x3 box. Cells connected by an X must sum to 10. Cells connected by a V must sum to 5. All X's and V's are given. There's a 3x3 magic square somewhere in the grid. I know that sounds kind of crazy. A magic square is a 3x3 square with digits 1 to 9, where all row, column, and diagonals have the same sum. We'll get to that in a second. For now, we'll start with the XV part of the puzzle, and let's take a look. Here's our puzzle. You can see, as usual, no numbers, but it's okay. This is a coloring puzzle, so we'll get started with coloring. The way I like to do these is I assign each way of computing 10, of which there are 4, 1 and 9, 2 and 8, 3 and 7, and 4 and 6, a color set, either yellow, red, green, or blue. I don't know specifically which one corresponds with which yet, but I'll still use the colors to help fill in the grid. And then I have the light version of those colors be a number from 1 to 4, and the dark version be a number from 6 to 9, since each way to compute 10 includes one of each. For each V has a 2 digits that sum to 5 in it, and there's 2 ways of making 5, 1 and 4, and 2 and 3. And I usually create a hot 5, which has the light red or pink and light yellow cells, and then a cool 5, which is light green and light blue. Again, I don't know whether 2 or 3 or 1 or 4 is the hot or cold 5. That will eventually be disambiguated, but that's just how I like to do these coloring XV type puzzles that NurglesGift is so good at creating. So it's important to remember that we have this negative constraint. All X's and V's are given, so if any two cells don't have a V between them, they can't sum to 5. So for example, if this is our cool 5, this would be illegal because we've declared that light blue and light green sum to 5, but there's no V between them. On the other hand, this would be legal because there is a V between them. And same for X's. If we have 2 digits adjacent to each other, but they don't have an X between them, they cannot contain 2 digits that sum to 10, which means they can't be the same color. All right, with that, I think we can get started. So I usually just start by finding a V in the puzzle somewhere that looks like it sees other V's or has a lot of other little connections with it. And I kind of arbitrarily choose colors to fill it in with. It doesn't really matter because we haven't assigned any values to these colors yet, except we know that these 2 are low and these 2 are high. These see this V, so we know this can't be the cool blue and green V. It has to be the hot red and yellow V, otherwise this cell could have no digit. So we'll just call that one yellow and this one pink, which gives us that is this one here. We can ask where light red and dark red go in this column. We know they have to be in one of these 3, but if either of them is in this cell, they will necessarily be next to another member of its same color with no X between them. And that's not allowed. So we know that our reds have to be on the edge, which puts our 5, which is gray, right in the middle. This can't be light red because it's next to the light yellow, but there's no V. And look, we just finished that whole column. Pretty nice. Okay, here we have another V. We know it's a cool V because it's seen by both cells of the hot V, but we don't know which cell is which, and now it does matter. We don't know that this is green necessarily and that this one is blue. Here we have another V, which is a hot one, which means this is a cool one. Okay. We know this must be the high version of one of those 2. I'm looking in this box. We know that each 10 must have a low and a high digit, but none of those low digits can be the cool colors, blue or green. So all of the low digits need to be coming from orange and red. So we know that all of these are either yellow or red. I said orange earlier, I meant yellow. I know it seems like kind of a mess of coloring, but it is still useful to know that there's still some limitations on what these can be. I actually know that this one can't be light because it's seen by both of these two, so this can't be dark. What else? That tells us that, what we have remaining is dark green, dark blue, and light gray. Dark green and dark blue are allowed next to each other. They don't add up to 5 or 10 because they're both high numbers. We know that this cannot be dark green though. Now we can ask, where can dark green go in this row? Can't go in any of these cells because there's already a dark green here. We already decided it can't go in any of these. Can it go in this X? The answer is no, because if dark green was in this X, it would have to have its friend light green, but light green's already in this row, so we actually know dark green goes right there. Okay, we can ask where light blue goes in this row. Can't go in any of these two because of that one. Can't go in any of these because we know one of these two is light blue, so it's got to be in here with its friend dark blue. Great. Now again, we know this is going to be a hot 10 because it can't be either the greens or the blues, but we don't know which is which yet. Not ready to say that this is definitely a hot V though, although we know that this can't be light blue. It could be light green, and this could be light blue. Let's see if there's any little nuggets for us to find. Taking a look here, we can ask what this X could be. Can't be a green one because then the cell could have no value. Can't be a blue one because both cells are next to blues, but there's no X's going across, so that would not be allowed. And it can't be a yellow one because then this cell would have no value. So we know it's got to be a red X. This one can't be light red because it's being seen by that light red, so it must be dark red. So that is light red. That opens things up a tiny bit here. And we know that our dark red is somewhere in here, but we don't know exactly where yet, so I don't know if I'm ready to put that in. Now, in this 3x3 box, we still need both light green and light blue, but we know it can't go, neither of them can go in this, so they must be in one of these 3 squares. And you might ask, can they just be in these 2? And the answer would be no, because then there would need to be a V between them, because we know they add up to 5, but there isn't. So we know that this cell must be at least one of them, and its friend must be somewhere on this side. Not a whole lot of information, but still I think can be a useful deduction. Let's see. I'm a little pause as I figure out what our next step is. Maybe thinking about dark blue here. Where can dark blue go? Can't go there because it would be next to the light blue. And we know that one of these two is a dark blue, so none of these can be dark blue. So dark blue must be in one of these two, which means this can't be dark blue. So we know it's 5, gray, and therefore these two are dark blue, dark green. Okay, wondering where a light green can go up here. Can't go here, or any of these, can't go there, so it's got to be one of these two. And we know whichever it is, the light blue can't be next to it. So if this is light green, then that must be light blue. If that's light green, that must be light blue. And that's just because they don't have a V between them. Thinking about dark red or light yellow, maybe? No? See, we know this is dark, but we don't know what it is. And this is light, but we also don't know what it is. We know that neither of these are blue, because then this cell would have no value. Let's see. I feel like it'd be great to know what this V was, whether it's a cool one or a hot one. But I just don't think we have enough information. Starting to wonder if we actually need to get this magic square rule in play. So let's talk about magic squares for a second. A magic square, again, 3x3 box. Doesn't have to necessarily align with these 3x3 boxes, so we could have a magic square here, for example. But the every row and column and diagonal needs to have the same sum, and it must contain the digits 1 to 9. If we know that every row contains the digits, has the same sum, and we know that, I'll restart that. If we know that a 3x3, this magic square, has all the digits 1 to 9, we know it adds up to 45, because that's the sum of the digits from 1 to 9. So if the rows have the same sum, they must have a sum of 15, and the same is true of the columns. And that is also true of the diagonals. It turns out that the only way to make a magic square is with the number 5 in the middle, and then each opposing side of the square adds up to 10. So if, let's say, this was the middle of our magic square, we know it's not, because that one, there's a 5. We know that that's the 5. If, let's say, this were yellow, we would know that this would have to be dark yellow, because these two have to add up to 10. Basically, any digits on opposite sides of the 5 need to add up to 10. Okay, and that isn't the 5. So one thing we can do is ask, where on this board can our magic square possibly go? It turns out that there actually aren't kind of infinite places. One thing about magic squares is, on any edge of the magic square, there can never be two digits that add up to 5 or 10. And let's take a look back here for an example of why that might be. So we know that every row needs to add up to 15, right? Every row in the magic square. If these two add up to 5, then this digit would have to add up to 10, but that can't be. And we also know that every column needs to add up to 15. If this were a 5 and we had an X here next to adjacent to the 5, then we know that this cell would have to be a 5 in order to make this column add up to 15, but there's already a 5 in our magic square. So anywhere that is adjacent to an X or a V cannot be the 5 of the magic square. And also, the 5 of a magic square can't be on an edge of the grid. So what I'm going to try and do right now is highlight areas of the grid where we cannot have the 5 of our magic square. It doesn't mean a 5 can't go there. It means the 5 of the magic square, of which there is one, at least one in the puzzle, cannot go there. So it can't go on any of the edges. It can't go in an X or a V because 5 is not allowed inside X's or V's. And we already know that's not a 5. And we just demonstrated that it can't be adjacent to any X's or V's. So that can't be because it's adjacent to both of those two, nor can that, nor can that, nor can that. This one was part of an X or a V. This cannot be. We already knew that. That can't be because of this X. This can't be, nor can any of those because of this V. None of these can because of this X. None of these can because of this V. None of these can because of this X. None of these can because of that X. And neither of these because of that X. This one because of that V. This one because of this V. And this is maybe looking like the only 3 locations that our magic square 5 can be. I'm just going to mark those. I think it was here, here, and here. And now what we can do is just test to see if these are eligible, if there's something that is maybe getting in the way for any of these that would allow us to discount it. I don't know if this will be fruitful, but this is just where my guess is taking me. If this were our 5, then we would know that on opposite sides, these digits would need to add up to 10, which means if this was dark blue, this would have to be light blue, but it can't. And if this was dark green, this would be light green, which is okay. Looking across, what could this be? It has to be a dark color. Could be dark yellow or dark green. And that would make this light yellow or light green, which is fine. In here, we've got to have whichever is not one of these. So it's going to be a hot color of some kind and its friend, but not very many restrictions actually there. Just this one can't be light red. So this one remains eligible. Here, I think we may kind of be in the same boat actually, which is a bit unfortunate. I was really hoping this would be fruitful. If this were our magic square 5, we know that this would need to be the opposite of this one. Which would be fine. It would just have to be dark green, so this would be light green. And this would need to be the opposite of this one, which would have to be dark yellow, because it can't be dark red. But I see no problem with that. Now here, interestingly, actually we do have something that makes this ineligible. Let's say this were a magic square 5. Whatever cell is in here, we know that it's, 10 partner is on the other side because the row needs to add up to 15. But its 10 partner is actually already in that row. So we know that this cannot be our magic square 5. Great. So we know our magic square 5 is one of these two cells. One of these two must be a 5. Does that help us a ton? I don't know. It does tell us that neither of these two can be a 5, because then neither of these would be allowed to be our magic square 5, but we know one of them has to be, which means our 5 has to be, or there has to be a 5 in one of these two. I would love to disambiguate this and figure out which of these two is our 5, our magic square 5. But I just don't know if I have it right now. If you're watching along and are seeing something I'm missing, I'm so sorry. I don't want to be too liberal in coloring everything in. Well, actually, I did just learn a little thing here. Remember we were saying that in this box, in this 3x3 box, the 5 has to be one of these two cells. It can't be this one, because then neither of our two possible candidates for our magic square 5 would be allowed to be placed. It can't be this one. But we also know that one of these two has to be dark red. So that at least gives us a pair, which narrows things down just a tiny bit. It does tell us that one of these two has to be dark yellow, which is quite informative, because we know that this cannot be, therefore, light yellow. Okay, making some progress. We're back in business. Hopefully it all doesn't just end there. We know we've got a light yellow among these. Wow, that didn't give us as much as I was hoping. Happens. Just do a little bit of coloring. It's a coloring puzzle. Actually, we know this can't be light yellow because this would be dark red, or light red, which it's not allowed to be. Oh, that is big news. That tells us what kind of V this is. It can't be a hot V because neither of the cells can be this light red. So it must be a cool V. Amazing. So we know it's got to be our cool light blue and light green. This one can't be light blue. Therefore, this one can't be light green. This is telling us that that's not light blue, so this is not dark blue. I think we're back in business. Oh yeah, this is going to open right up. I hope. Thinking about what kind of X this can be, we know it can't be blue or green, and it also can't be yellow, because both yellows see both cells. So it has to be red, which means this one has to be the dark red and this the light red. Now, if this cell, I guess maybe just an easier way to think about it is where can light red go in this box? Can't go in here because of this one, and can't go in here because of this one. So it must be in the 10 with its friend dark red. And now we can ask where the yellows are going. They can't go next to each other because there's no X there. So we've got to have at least one of them down there. And at least one of the others is up here, or the other is up here, but we don't know exactly where it's going yet. Now, one thing about this little activity down here is we have actually ruled out this from being an eligible magic square 5, because if this were a magic square 5, the opposite of this would have to be a light blue or light green, but those are already taken in the box. So, big news. That's not our magic square 5, and this one is. So I'm just going to leave the green circle there so that we know that that is our magic square 5, and that is going to help us a lot, because now we know on the other side of it, the digits need to add up to 10. So we know that must be light red, which is going to clean some stuff right up. So none of those are yellow. Everything's looking good so far. And on the other side, we know that this must be dark yellow. On the other side, we know that this must be dark blue or dark green. It can't be dark blue, so it must be dark green, which means this must be light green. This can't be light green because it's next to the dark green, but there's no V. So we have a light green and a gray somewhere in these two. I'll just mark that. Here we need dark blue, but it can't be next to the light blue without an X, so it must be there. And this tells us that that must be dark yellow. And in this row, what are we missing? Light green, gray, and dark green. So we know one of these has to be dark green. Well, actually, it has to be this one. So light green can't go there anymore because it would be next to the dark green. But there's, again, no X, so that must be gray, which disambiguates these two. And down here, what are we left with? Light green and yellow. Well, we know the answer to that one. That one can't be light green. And down here, what are we left with? We are left with dark yellow and dark green. And not enough information to decide which is which yet, but that will come soon enough. Just going to finish up our magic square by knowing that we need to have our dark blue on this side, on the opposite side of its light blue friend, which is going to tell us that that's not dark blue. Looking up here, that can't be light green. Great, making so much progress. This can be neither light yellow nor dark yellow, so all it can be is gray, and we know that this must be the yellow that's remaining. Can't be dark, so it must be light. And looking across here, we are just missing dark yellow. Looking across here, we are missing dark red and gray. And these two must come from light yellow and dark blue, and not enough information to disambiguate just yet. But again, that will happen very soon, I predict. Thinking about what this X can be, are we ready for that? Actually, I don't know if we have enough information for that just yet. Ignore this one. We do know the temperature, whether there's a hot or a cool V. It can't be the hot because there's already a light red here, so we know it must be cool. it's seen by the light, that cell's seen by the light blue, so that must be light green. And what do we have remaining in this row? We need gray, dark green, and light yellow. This can't be dark green. This can't be gray because of that one, and that can't be gray or light yellow because it's next to the light red. So this dark green is now seeing that one, which sees that. Now we can think about this X. Can't be a blue one, can't be a red one, and can't be a yellow one, so it must be a green one. Which means we know that that is not the dark green. And looking up here, what are we left with? Dark red and our gray, but this gray sees it. And therefore these two must be dark yellow and light blue. And this cannot be dark yellow because this would have to be light yellow, but that is next to the dark yellow with no X, so that must be our light blue and our dark yellow, which means this is our dark blue, and that is clearing things right up for us down there. Almost done. In this column, we need light green, which clears these up. And still in here, we need light blue and light yellow. Looking across, we need light yellow, which has to go there. We need, looks like dark red and dark blue. So that's got to be the dark red and that are dark blue, which means that's not dark red. And we know that we have our dark yellow here and our dark green and a light red. And we're done with the coloring part. Are we done with the puzzle? No, we're almost done. So we know all of our grays are 5s, but now we've got to figure out the rest. And this is where our magic square logic comes in. So you might think, well, by construction, we know that we've satisfied the constraints that, you know, on either side of the 5, we have digits that add up to 10. So what more information can the magic square give us? But there is information. So we know that on this edge of the magic square, that these two must also, or this column must also add up to 15. To add up to 15 with 2 high digits coming from 6, 7, 8, and 9, and a low digit coming from 1 to 4. If this low digit was 4, there'd be no way to make these 2 digits add up to 11. So we know it can't be 4, so it could be 1, 2, or 3. Actually, it can't be 3 either. If it were 3, we would need these 2 digits to add up to 12, but there's also no way to do that with 2 unique digits from 6 to 9, so this can't be 3. So we know our light blue is either 1 or 2, and our light green is 3 or 4, and our dark green is 6 or 7, and our dark blue is 8 or 9. And again, we have a similar scenario up here where we have 2 high numbers surrounding a low number using the exact same logic that we did for this one. We know this can't be a 3 or 4, so it must be a 1 or a 2, which means our dark red must be 8 or 9, our light yellow must be a 3 or 4, and our dark yellow must be a 6 or a 7, and we're very close to this being done. Now, we know that these two need to add up to 13, which is telling us that our blue, our light blue, is 2. And you know that's going to open everything right up. Dark green is now 8. Sorry, dark blue is now 8, which means our dark red is 9, and our light red is 1. Our yellow is therefore 4 and 6, and our greens are 3 and 7. We're all done. Let's just take a look at that magic square again and see what our sums are. So indeed we do see that each column adds up to 15. Each row adds up to 15. And each diagonal adds up to 15. And that's the puzzle. It was a pretty interesting one, I would say. Anyway, thank you so much for watching, and I'll see you in the next one.